Hello. Hello, everyone. Yes, So, hello, everyone. So, this is the special type of session in which we are trying to solve some question. Here's a question live. There is no need of any helping through the internet, through ChatGPT, Claude, or another AI. So, we are trying to break down the question. So, let's see how much we have to solve and how much percentage we are able to solve this question. So let's see. So I have a question. Let's break down that question. So the question is given that we are given. So as we state, there is a timer section or not. Let me find the timer system. Mm, Timer clock. I cannot timer time. I can device frame. No need. No need. So okay. Okay, leave it. It's the time started. Let's know the time. So this is a four code challenge. Four code challenge. So we have we have we have 30 minutes. So let's start. So the start time is equal to, so start time this is 10 11:45 p.m. So 11:45 p.m. and this is today's date is 8 November 2025. So let's read the question as the question suggested. So let's read and write the question. So we are given with a matrix of n cross n. So n cross m is a matrix where each of its cell contain some coins. So each of the cell contain some coins. So each of the cell contain some coin. So each of cell contain and count the number of ways to collect the exactly k coins. So we have to collect exactly k coins. So we have to collect exactly k k coins while moving from the top left to matrix to top left to bottom right one. So given matrix we have contain coins to collect exactly k coins from the top left to bottom from the cell, and we can only move through the cell of I plus 1 comma j, yeah, I comma j plus 1. So we can move through the rows or columns. So okay, so k is given as 12. So in how many, so what we have to return, so we have to return so two possible paths to get exactly. So we have to find the path sum is equal to exactly k. So and the so matrix is given. Okay, let's leave this space coding part. So let's do. So matrix of given of size 1 comma 2 comma 3, 1 comma 2 comma 3. After that another having another having 4 comma 6 comma 5. And after that 3 comma 2 comma 1. So this is the matrix. So this is the matrix as a possible one. When we go through 1 2 6 1 2 6 no, 9 11 12. So 1 2 6 2 through this, and 1 2 3 yeah, 1 2 3 5 1. There is two paths through which we have to reach the position. The path, so exactly. This is simple. I think this one is exactly the problem of dynamic programming. So we have to move from top left to bottom right. But this dynamic condition is the coin and the collected coin become is equal to the. So let's try to. Uh, so the algorithm will be the algo will be algo. Let's try to code. Let's try to code this question. Tutorials. Editor section. So we want to see the editor section. So number of paths. So number of path, null vectors, and exactly k. So in code, so int. So let's move to the document portion. For code challenge part. So int 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 number of paths. So number of paths is equal to vector of vector of vector of. So int is a type and address matrix int k and k. So what we have to do? So we have to int n is equal to nums of size. We have to first of all recursively reach the answer, and after that we have to memorize. So we have to return what we have to return number of pairs. So return the, let's explain solve function containing the matrix mat integer k and integer k starting from 0 0 0 comma 0 starting or starting column. Okay, so let's add the int solve function consisting of uh, vector of this one, vector of vector this mat. Okay, okay, and the integer k. Okay, and int I and int j. Okay, so if I or j reach to the int n is equal to int n also. So int n. Okay, there is no need to pass this one, but let me pass No need to. Wait. If I is equal to n minus 1, if starting from 0, and j is equal to, if I is equal to n minus 1 and path sum is equal to, also sum is equal to 0 and sum is equal to 0. Okay, so in this case we have to pass sum and sum as a 0. So int sum and sum is equal to k. So in this case we have to return let's see what we have to return. So return count. So okay, let's see, we have two choice, either move. So we have either two choice, move the cell like this. So two choice. So down mat of I comma j plus solve function mat of k comma I plus 1 comma j and sum int right side, same mat of I comma j solve. Okay, return down plus right, down plus right. Number of coins, the matrix. The constraint is small, and so what we have to do, count. So we start from the, we have to reach to n minus 1 and n minus 1. So count the number. So dynamic programming is the approach plus recursive plus memoization. So we go through the all the cells through down matrices. CPP is recursive one. So let's see the approach. So in this question, let's see the approach, what we have to do. First of all, in the main function, in the function function. In function portion we have to write the matrix n is equal to nums dot size or matrix m mat dot size, okay, size, okay, and the m is equal to mat of 0 dot size, okay. Then after that we have to call the before memorization on all things. I only know that we have to return solve function having the matrix from 0, starting from 0 comma 0, and the target value is equal to k. So after that we move forward for the main function, where we write the solve function. So inside the solve function what we have to write? So inside the solve function what we have to do, first of all pass the matrix passing the matrix I n j and k. So check the base case. So base case condition will be, if I is greater than is equal to m, okay, I is greater than is equal to n, or j is greater than is equal to m. So in this case we don't get any answer, so in this case we have to return, okay. After completing base case we have two options. Either first of all we have to check, either we have to check the remaining elements what needed. If we move right, so we have to check if the remaining number is less than or is equal to the right element, if the or the remaining element is greater than is equal to down element. So after, if the remaining element is less greater than the element on that grid, so in that case we move to that pass. So we check int remaining is equal to k minus mat of i comma j, okay. So in this case we have to check if our remaining value become less than 0 or something. In this case we have to return 0. So in this case we have to return 0. So all the base case and everything is completed here. So we move forward for the main uh, codes, okay, remaining on this one. So right side in, and we have to choose move int. For the right side int rigst right is equal to, in right side same, nothing we have to do. Uh, we have to pass matrix, okay, I plus 1. For right side we have to I same j plus 1, and the remaining element will be given. And for the down right side and for the down, have to solve the matrix same. For down I plus 1 and j remains same, and the remaining element will be there. So after this we get the answer from both right plus down. So from this we get the right or from the down. So return from right plus down, okay. So this is the workflow. I think this is the workflow of the code. So this is a recursive one. So in the given question the three things are changing: I, j and the remaining elements. So we have to use 3D vector to memorize this one. So let's use this question using solving memset. So we have to use memset. So where we have to write the things. So let's add using memset. So above all this we have to pass int n. So int n, no, int n is already, so int n and m. So here we have to remove the n and m, integer one. So okay, we have removed n and m, okay. So after that we have to initialize a vector, uh, 3D vector. So we have to name as dp size of constant. We check the constant. So if the if the rows goes to 100, we have to write 100 plus 1. If our column goes to 100, so we have to write 100 plus 1. And we have to check our values, so value might not exceed the 1001 value. So this is cool. Okay, till now we are doing great. So let's move in the main function. We have to initialize the 3D vectors. So 3D vector, so we have to like write memset. So we have to write like memset of what. Memset memset of dp mems of dp initializing of -1 size of dp size of dp. So this happen here. So memset of dp, uh, this will be done. So before this we have also memorization check. So memorization check, how we check the memorization. So memorization check will, so if how we check memorization check look like this. If dp of I if you have dp of I, j or k is already exist, it not is equal to -1, this means that the answer is stored already. So we return this one. Okay, so we don't need to write this much. So and in finally we have to store this answer in dp of I or j. Okay, so returning portion will be returning dp of, so dp of I comma j comma k, the answer stored in this. So simply in 4 to 5 steps we have to solve the through the answer memorization and all these things. Writing n on m, returning a solution, solving for the base cases, checking the remaining element. If remaining element exists, we run for this. So in the 4 out of 4 code challenge, we completed the 1 So 3 code are remaining. So 3 code are remaining. Okay, so let's move for the next question. So where to tile a floor. So next question will be um, so next question will be uh, just like a given a floor of dimension. So let's see the next question. Let's see the next question. So given a floor of dimension, so let's a floor given of dimension, sub dimension, what dimension of 2 cross 2 cross n. Okay, and the tile of dimension and the room dimension is 2 cross n, and the tiles dimension is equal to 2 into 1. So and the task is to find a number of ways. Same dp question, number of ways number of ways the floor can be tile. A tile can either be horizontal, like domino question. Tile can be horizontal, horizontal like one cross, two, or vertical like two cross one. Okay, so this one be the things. So given floor, so how many ways we can fill this? How many? Find the number of ways through which the whole floor can be tiled. So so let's see if we have n is equal if n is equal to 3 is given. So n is equal to 3 is given. So what we have 2 cross 3 room. So two rows and 3 column, and we have to fill with the 1 cross 2 or 2 cross 1. So how we fill how number of ways to fill this? So simply we place three three horizontal one. Okay, one row two column. Okay, number of ways. So we need number of ways through which we fill this tiles. So we have to see. So as we see the explanation, we need three tiles to three tiles to do the tiles box of say. So place the three tiles vertically. So number of ways. So we have to find number of ways to fill this. So just imagine if we are given n. So n is equal to what we have given. If we have given n is equal to 4, this means that 2 cross 4. So in how many ways we can fill? So in 5 ways, sorry. So we have to place 2 cross 1 tiles 4 time. So 1 2 3 4 time. So one way. Okay, and 1 cross 2 tile 2 times, 2 times like this and 2 times like this. So how we check? If we solve one of the approach, so then recursive after that the recursive solution can solve the rest of this. So it is similar to like dominoes trinomials like problem, but how can the question name suggest the ways to question in name suggest as question name if you want to find this question on internet, so find as way to tile a floor. So the question is clear. 2 cross n dimension is room tiles is given as 2 cross 1. So number of way through which we can place the tile in horizontal one. Horizontal one mean one row, two column, and vertical and two two rows, one column. So like placing the tile like this in in horizontal this one, and in the vertical one we have to place the tile like this. So how we have to solve this question? Now simply the code start with a number of ways or intent. So when we start this question, 11:45. So 15 minutes taken, 27 minutes taken already. So any approach or algorithm. So there is no approach and algorithm thinking in my mind. I'm not thinking any approach. So I know how to solve this question. Simply I know I have to use DP. I know. So first of all, we have to create a recursive solution. Okay, we have to recursive solution. So after that, we have to So we have only 5 minutes to solve this question. So in four code challenge, we have to only and till now I'm thinking that only we have to solve two questions. So so let's. So number so so I'm trying thinking recursively. So I have focused to fill the last part of the floor. So if the last tile is placed vertically, so we have to. So I think this one is a simple one. Let's see the code portion. So in solve function, in count way use only int n. So in which we have to return the solve function in which we have to pass n. Okay. So let's see the solve function. So in solve function just return the number of ways. So we have to write this and int n. Okay. Till now, if n is less than is equal to, so we can't place the tiles. So in this case we have to return return 0. Okay. So so if you place this n is equal to 2 is fixed, and or placing covering one block or covering two block is important. So what do we do? So two cross one floor only one way, but two into two cross the two way vertically, or two cross two floors. So one is horizontal place and two tiles placed vertically. So it simply is just like returning the solve function for the n minus 1 plus solve function for the n minus 2 n minus 2. So this approach we place all the tiles completely, but we are changing only one value. So we simply write vector of int of dp of size and plus 1 of size of minus 1 if dp of I and dp of n is not is equal to -1. In this case, we have to return dp of n. In this case, dp of n, or we have to store the dp's value. So dp of n is equal to this. So here is the solution for the placing the uh, placing the point. So we have to check this approach. Let's see, is working or not. We solved two questions of the recursion. So 4 code challenge completed with the only 2 questions. So rest of 2 questions are remaining. So in the next session, we try to solve both 4 questions totally. So thank you for joining for this session.